Hello class and welcome to lesson 4.2, the parabola of best fit. So today what we're going to do is we're going to start off with taking a set of data from taking a look at perimeters and areas of squares. So that's our investigation today. And then we are going to break it in different parts. We're going to collect the data. We're going to graph it manually. We'll use technology to graph it. And then we'll learn about the graphing calculator and how it will actually give you the quadratic regression, which is the curve of best fit. Similar to the line of best fit when you got a linear relation, but the curve of best fit is when you've got a non-linear line. So let's take a look. Let's do part one first, folks. We're going to collect data. So when you have a square, ladies and gentlemen, and you are looking for perimeter, that equals 4 times the side length. So if the side length is 1, ladies and gentlemen, you're going to write down 4 times 1 because there's 4 sides, and the side length in this case is 1, so that equals 4. Let's go down to the next one. 2 is the side length now, so 4 times 2 equals 8. And these are all in centimeters. So we're going to follow the same pattern all the way through to 14. Okay, so you can actually go like this and then do the answers after if you want. That's what I do. Okay, so fill these in, folks. All right, let's do our 4 times multiplication tables. All right, so you're going to have 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, and 56. So that's the perimeter. Okay, that's adding all the side lengths together, and that's in centimeters. When we do the area, remember it's length times width of a rectangle, but side times side because we're taking a look at a square. So side squared is s times s, so that's side squared. So that's where that formula comes from. And notice the units is in centimeters squared. So what you're going to do is take the side and square it. And that equals 1. So you can, again, write the same pattern down. You're going to take 2 and square it, 3 and square it, 4 and square it, 5 and square it, 6 and square it. All right, so let's fill in our answers now. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 169, and 196. All right. So now we've got our data filled in, ladies and gentlemen. Now what we're going to do is we're going to display the data. So now we're going to create an accurate scatter plot on graph paper. So if you have graph paper, great. If not, just go to the website, go to the Google and print off a graph, a grid. So you could do Google Images, graph paper. And what you're going to do, folks, is you're going to plot graphs. So use a full page, ladies and gentlemen. And if you can get another page while you're at it, because you're going to need 1 page of graph paper for homework. Okay? So what we're going to be doing is we're going to be plotting the perimeter horizontally. So perimeter is going to go this way. Okay? And perimeter is in centimeters. And then we're going to do the area vertically. So the area goes here, and area is in centimeters squared. So this is going to be an area versus perimeter graph for title. When you label a title of a graph, usually it's going to be the dependent variable versus the independent variable. All right, so we've got our graph set up. We need to take a look at where we're going to start our perimeter. We're going to start it at 0, and our maximum perimeter, ladies and gentlemen, is 56. So let's go to maybe 60 so you can see it. Okay, and you're going to plot this. You can't just sketch it like I'm doing, okay? The area, we're going to start at 0, and the maximum area, we have 196, so let's go to 200. Find an even scale that works on each of these, okay, to get to the 200 and to get to the 60. And then you're going to plot your data. So when you plot your data, you know that it's going to look something like this. And I want you to visualize it being half a parabola, okay? All right? Because when you take a look at the units for centimeters, for area, it's centimeters squared, which creates a quadratic equation because the units are squared, right? Just think you've taken the side, you multiplied it by the side, so side times side is side squared. All right, let's use part 3, which is the technology option. So I just need to minimize this for a second to get my graphing calculator up. And let's see, it's going to take a minute to probably load that. So hopefully you're having a great day while this loads, guys. Okay, so what we're going to do now, I'll just clear this. So you got to reset things. So I'm going to go to y equals. So I'm going to press clear, down arrow clear. I'm going to go to second plus sign 722 to default set. And I'm going to clear the list. Second function plus 4, enter. All right. So part 3, folks, says on the next page, I'll just flip back to my lesson. So part 3 says use technology to estimate the equation. So first of all, we're going to create a scatter plot. So if you're wondering where this lesson idea came from, I borrowed it from the textbook. So on page 172, you'll notice that it asked us to create the table. We've already done the table on the first page. Okay, now we're going to do part 2, which is use a graphing calculator to make a scatter plot. So follow the steps. We're going to enter the data into stat and equals, or stat and enter. I'm going to press stat, and I'm going to press enter. And under L1, ladies and gentlemen, we're going to put down all of our perimeters. So we're going to go 4, enter, 8, enter, 12, enter, 16, enter, 20, enter, 24, etc. Keep going all the way down the list. Till you get to 56. Okay? And we're going to go over and we're going to put the corresponding areas in. Sorry guys, it just is a little bit, oh, see, I made a mistake there. So that's got to go 81, enter, 100, enter. I'm almost done here, guys. Okay, make sure, ladies and gentlemen, that you got equal data points in L1 and L2. All right, go back to our lesson. What does it say? Enter them in there. Okay, now it says to set up a scatter plot. So you have to go to second. So here I am right now. Second y equals, and we have to turn the plots on. So I go over here and I go second y equals. I got to go enter, and I got to turn the plots on. And when I turn plots on, I need to also hit the scatter plot button. And notice when you hit the scatter plot button, it'll say L1, L or L1 for your X list and Y list for L2. So it's going to graph in the x-axis, which is our horizontal, L1, which we put in our perimeter. And in the y-axis, we're going to be putting what we put in for L2, which is our area, and that's what we want. Okay? But before we graph it, we got to put an appropriate window on. So let's press window. And X on our x-axis we have perimeter. So our 0 is our minimum value for perimeter, and our maximum we said was about 60. Okay, our minimum area will be 0, and our maximum we said is around 200. Okay, and let's press graph and see if we get our scatter plot. Okay, so let me see if I can just quickly go back, and I'm going to capture that, and hopefully my capturing technology works a bit better. Here we go. So that's what it should look like. Just move it over here. All right. Good. Oh, haha, look. That matches the one there. All right. So what we need to do now, folks, is we're going to, it suggests that there's going to be a quadratic relationship between the areas and perimeters. If the parabola best fit were to be drawn, it would pass through the origin. Recall that the equation of the parabola passing through is y equals ax squared. So we talked about a last day. So what we're going to try to do on the next page is we're going to try to guess that equation, guys. Okay, so when you graph equations in the form y equals x squared, different values of a will come in. So the first thing we're going to do is let a equal 0.2 and sub it in for a in that equation. So I'm going to go to my graphing calculator, go to y equals and go 0.2 x squared. Let's graph it and see what happens. So notice we've got that graph, folks. That is exactly the same one as right here. Okay, but we want that line to get right on our dots. So we're going to have to make it a little bit bigger. Okay, so what do we need to do is figure out what values we're going to enter in for y. So let's just go back and try another one. So let's go to y equals and let's go 0. Now we need to make it wider. So let's go 0.08 and see what happens. X squared. Okay, let's graph that. Is that getting closer? Oh, it's getting closer. Okay, but we need to go a little bit smaller. So let's go to y equals and go 0.07. Let's see if that's getting better. Oh, we're getting pretty close. We're not quite there. Okay, how about I go 0.06 and graph it. Oh, 0.06 is a little bit too much. So I got to go in between there. Holy moly, we're getting pretty accurate here. 0.06. How about I try 2.5 and then x squared? Oh, sorry, I forgot my x. Okay, let's graph that. Take a look, ladies and gentlemen. Wow, we just figured it out. Okay, so that's the one we wanted. And what was a, guys? 0.0625. Cool. So let's take a look at our equation. So we went and we entered all these evaluations in, and we said we had a equals 0.0625. Okay? So we found out our equation by guessing that. However, that's the estimation part. The great thing about the graphing calculator, folks, is we can actually get the line of best fit. Okay? We don't need to guess around. It will calculate it for you. So what we need to do is do the curve of best fit using quadratic regression. So in order to do this, we need to turn the diagnostics on. So that's in your catalog. So let me go to the graphing calculator and we'll turn the diagnostics on. What does it say to do? Go to the catalog, which is second 0, scroll down to where you see diagnostics on and hit enter. So let's do that. So I go to catalog, which is second and 0. Scroll down. I know there's a lot of functions in the calculator, guys. That's why they can't have them all on at the same time. Okay, so we're getting close. Okay, so we've got diagnostics. That's off. That's on. So hit enter, and then you hit enter again. It says done. Okay, so I've got that. All right. Now we need to go back to our lesson and learn what steps to press. Okay, so right now we're going to be doing these buttons. Okay, so just follow along in your textbook as I do this. So I'm going to go stat over to arrow over to the calc menu. Okay, so statistics and over to the calc menu. And notice where it says quadratic regression. That's number 5. Okay, I'm going to tell the computer where my data is. I want you to do a regression on L1. Look near the number 1, guys. See how L1 in my case is blue? Normally it's going to be yellow if you're using a regular calculator. So I got to go second 1, saying my data's in second 1, comma, second 2, which is L2. Okay, so that tells me where the data is. But now I'm going to get it to come up with the equation. So I'm going to go comma, vars, over to y-vars, because I'm going to get the equation to come in. I want it in the form of a function, and I want it to go wherever I have y equals in my equation. So you've got, what you're doing is saying to the calculator, I want to do a quadratic regression using my data from L1, L2, and I want you to put the equation in Y1, which is in our Y equals up here. So it'll eventually come right in here for us. Okay, guys? Isn't that cool? So let's press enter and we'll learn some things. So as soon as I press enter, we've got our quadratic regression, and it gives us our A value, our B value, and our C value. Okay? All right. And we're going to go to Y equals, and our data is in there as well. Okay. So let me go back to my stat for a second and go to enter. Okay, so I've got my L1 data there, my L2 data there. Okay, and I want to do a quadratic regression, so I've got that. If I press graph, oh, it's a little off, ladies and gentlemen. So somehow my quadratic regression didn't work. So I'm going to try it again, okay, because it should go right through there. So I'm going to go to Y equals, and I'm going to clear that. And I'm not sure why it didn't work. Let's try it again. So stat, over to calc. I want to do a quadratic regression, which is 5. Okay. I'm going to tell you to put the L1 and L2 on. Okay. So we're going to go second 1, comma, second 2, comma. Tell me where I want my vars to go. Okay. And let's try that again. Otherwise, I've got some data in there wrong. Folks, I need to do a further investigation. Let me go to my stat button. Let me go to enter. So maybe I've got some wrong data in here. No, it looks like it's done right. I'm a little perplexed, ladies and gentlemen, because I'm not getting the right value. Okay, let me just pause for a second and see why I don't have it. All right, folks, I found out where my error was. Take a look here in my data. Instead of doing 32, I did 332. So let's erase that, and we will put that data point in correctly as 32. Okay, that was my fault. Okay, so if I go to my graph, got our data there. We're now going to redo this linear regression, okay? All right, so we're going to try that again. And hopefully, let's keep our fingers crossed, hopefully it'll work this time. So let's go stat over to calc. 5. L1, comma, L2, comma, vars, tell me where I want it. Please work. Aha, there we go. See what happens when you have the data incorrectly done? So there's our A value that we came up from before. Okay, and remember the correlation coefficient we talked about before, which was R. If you take the square root of R squared, which is R, it's 1. That means that's a perfect relationship. So when I press graph, look at that. Equation goes right through all the data. And again, the equation is there that we needed to have. Okay? So that finishes that, ladies and gentlemen. So let's go back to our lesson, okay, and just reiterate what's happening. So this just talks about the R squared value, okay? The fit is perfect when it's like that. That means there's no discrimination, and the regression is exact. All right, so for your homework, ladies and gentlemen, you're going to be manually doing a graph of height versus capacity from page 32. So you're going to do height as your vertical and capacity on your horizontal, and you're going to try to line the best fit. It's not going to be as easy as the one we see here. So just plot the data and try to get a nice curve on it. It's not a perfect curve, folks. If we had more time, I'd do it on the graphing calculator, but I think you are done with listening to me on my lesson. Okay? We can try it in class if we need to. All right. Thanks for putting up with me, and sorry about that mistake. I entered my data in wrong, but we got it figured out. That's the good news. And I hope you have a great day. And